Swayam Prabha. Digital India. Educated India.
Good morning. Welcome to the last lecture of this week of this ongoing online course on understanding and reducing greenhouse gas emissions, and we are focusing on scope 1 and 2 emission reduction through building design and construction. By this lecture, what we have already seen is we have seen different strategies for refurbishment, renovation and retrofit. We have seen the strategies for them, we have seen the emissions that result from renovation versus the rebuilt exercises, and then we also saw a case study. Now, in today's lecture, we are going to look at couple of more case studies through which of net zero energy buildings largely, and through these we will try to understand how have people tried to reduce their emissions, what have different clients and architects done in order to reduce the emissions through their buildings. Now, before I move on to the case studies, we have to clearly understand what are these emissions, and as we have very clearly seen, the maximum amount of emission that is coming from the building assets, the buildings as assets, is going to be scope 2 emission, and scope 3 emissions are also there, which are like embodied due to the use of the materials. So, it is through the value chain. So, the kind of materials that we are using will influence scope 3. We are usually not looking at this scope 3 emissions. We are here looking at scope 1 and 2 mainly, of which scope 2 forms the most significant part. Scope 1 will be where we are talking about, say, the refrigerants, the leaks that are happening through the HVAC system, if there is a direct combustion process for cooking or for some other process. So, that is what we are looking at scope 1, which is usually in a lot of buildings that we will see today, we will find that scope 1 emissions are usually very limited. But scope 2 emissions, which are mainly due to the electricity that is consumed in these buildings, this is the most significant portion of this building as an asset. So, we are going to focus our entire discussion on reducing this scope 2 emission and little bit of scope 1. We will keep the scope 3 out of the discussion, which is anyways the focus of this course is scope 1 and 2. So, let us go ahead with the case studies. So, today in this lecture I am going to give you examples of 4 of these case studies. One is Unnati office building in Greater Noida, Bhavar residence in Chennai, Jaquar headquarters in Manesar, Haryana, and Indira Paryavaran Bhavan, which is a government office building which is in New Delhi. So, 4 of these buildings, and you can find the details, and there are many more case studies which you can find on this website, which is nzeb.in, netzeroenergybuildings.in, and there is a section on case studies and what have different building owners, the building clients done in order to achieve an energy efficient building is what you can see here. So, let us start with the case study. So, we are starting with Unnati office building in Greater Noida. So, this is basically the regional headquarter for Gainwell Common Sales Private Limited, and it is on a it is part of a 5-acre campus. So, what they have done primarily is, so it is not just one building in isolation. So, 2 strategies clearly when we have to reduce the energy consumption and the emissions that are accruing due to the electricity consumed, there is a 2-pronged approach. One, to reduce the consumption of electricity, which is what we have seen, and this is the low hanging fruit. It is much easier and cost effective to do that. So, first they have reduced the energy consumption, they have made the building more and more energy efficient through design and construction both, but largely for this reduction in energy consumption, design is the most important, most significant contributor. And the second part of it is when once we have reduced the energy consumption and we have made the building highly energy efficient, we generate electricity, we generate energy on site and use it in this building, so as to further offset the need for taking in electricity from the grid. That is what exactly that has been done in Unnati office building, and majority of the net zero energy buildings will have this approach. Even if we are not aiming for net zero status, we have to follow the same approach. 1, reduce the energy consumption, 2, produce the remaining. So, what they have done, what they have been able to achieve through different strategies, which I will show you now, they have reduced the energy consumption by 59% from the conventional building's baseline. So, this building, this office building which has been designed, consumes 59% lesser energy than a conventional building, and then of that energy whatever is required, they generate around 40% of this total energy through the on-site renewables. So, we are talking about generation of approximately 25% of the energy requirement which would have been required in conventional building, but here they would actually be requiring to take from grid only 25%, which further can be offset by investing in offshore renewable energy projects. So, the strategies that they have, and we have talked about all these strategies, there is nothing new that we are talking about, but we are only seeing a proof of application of these strategies and thereby the results that people have achieved. So, first is passive strategies, the designing of the building. Before even going for MEP systems or materials, the first is to design it right. What are the passive design strategies? 1, orientation. So, the building has been oriented rightly so as to reduce the excessive heat gains in this climate. 2, landscaping. So, there is a mix of existing and new vegetation. 30% of the site has been retained as green, unbuilt, and they have covered 25% of the total site with shrubs and trees all being native. So, we are not even talking about the water efficiency here, we are only looking at energy efficiency, but the moment we reduce the requirement for watering the plants for irrigation, we are reducing the hours for which the pump would otherwise be run and thereby impacting the energy consumption of the building. So, everything, any resource saved is actually energy saved in some or the other form is what we have to understand. The third passive design strategy that they ensured is having daylighting in all the habitable areas. 90% of the office spaces including core and service areas are daylit in this building. So, they have shallow floor plates, and how have they been able to achieve that? They have introduced a courtyard. Usually what happens is that when we do not have courtyard, the floor plate becomes very wide and it is impossible to light up the center of the plate, the middle part of the floor plate. So, what they have done? They have cut a courtyard which has enabled shallow, narrow floor plates, thereby enabling daylight, penetration of daylight from both the sides. So, every part of this building, so if you see here, so every part of this floor plate is actually getting lighting from both the sides, from this side and that side. So, the floor plate, the width of the floor plate is very narrow, that is what they have maintained. Another passive strategy that they have used is ventilation, increasing the ventilation rate over and above what ASHRAE has prescribed, ASHRAE standard 62.1 has prescribed. So, now this particular point will result in slightly higher energy consumption than the conventional, because we are increasing the ventilation rate over and above the standards, but it will result in better indoor air quality and better occupant comfort. So, not compromising on the occupant comfort is what they have prioritized. However, it will result in slightly increased energy consumption. Then once the design has been done properly, next they have come to building envelope and fenestration. So, this was about the plan, and then we come to the envelope. So, fenestration window wall ratio has been limited to just 30%. So, if you look at ECBC, what we have seen that 40% is the optimum. So, ideally it should be between 40 to 60%, and here they have further reduced it to 30%, but distributed. So, the surface area has been increased by providing a courtyard, and of that surface area 30% of the wall surface is window, and that is sufficient enough to daylit all the habitable office areas. Once the fenestration has been provided, designed, after that high performance envelope insulation has been added. So, the building envelope is now insulated, and we will see very interesting detail we can find here. So, if you look at the picture, so you can see bands here. So, these are the bands which are now projected. If you see this, so here is the window, and this is the band which has been projected. This is the concrete slab which is projected out, and this space which is now created acts as a buffer. And what is happening? The HVAC ducts are running through this cavity that has been created. So, this cavity protects the interior spaces, the indoor spaces, from receiving a lot of heat. This window gets projection which is continuous, it remains shaded for most of the time, it cuts off the direct radiation, but allows the penetration of daylight, sufficient daylight, because it is like a continuous window that has been provided. And this cavity is housing the HVAC duct, which is anyways insulated. So, that is how they have kind of insulated the fenestration and the envelope, the walls as well. Once the design and the construction is in place, on top of that mechanical and electrical and plumbing systems have been planned. So, then lighting design. So, efficient lighting fixtures have been used. So, LEDs have been used. Similarly, optimized energy systems and HVAC systems have been used. So, if you look at this schematic, so this is where the HVAC ducts are running. These are the supply ducts, and they will remain insulated within that cavity. So, the supply is from the bottom of the cool air, and the exhaust has been taken above the corridor, which does not require the clear height as high as the habitable spaces, and the exhaust is running. So, it is a laminar flow. The windows and we also see that there is a light shelf which has been provided. So, if you look at this, so there is a vision glazing and there is a light glazing with light shelf. So, the entire space gets properly daylit, and the ventilation also happens properly. So, enhanced ventilation strategies, enhanced more efficient lighting design. Before these two, before more of the mechanical and electrical systems, the building design has been done properly. Further, the indoor air quality and then monitoring and measurement of this indoor air quality and the indoor environment has been ensured to provide the occupants the thermal comfort and the comfort that they deserve. Together, this entire building, as we saw, reduced the overall energy consumption by 59%, and of the remaining energy whatever was being consumed, 40% of this energy consumption is now coming from the rooftop PV plant. So, what they have done, there is a shed at the back, the industrial unit at the back. The entire industrial unit has been fitted with the PV cells, photovoltaic cells, and it generates around 146 megawatt hours per year. This is sufficient enough to power this building. And one more strategy which we have not discussed is that this entire roof is a green roof, thereby further reducing the requirement of energy because the heat ingress has been reduced. So, this is, if you look at this, we are largely talking about scope 2 emissions here, because we are primarily looking at reducing the energy consumption. and that is what we will see in most of the case studies, most of the examples, that when it is a large business and we are talking about the carbon emissions, reduction of carbon emissions, the scope 2 emissions are coming significantly from the building assets, whether they are leased or they are owned. The energy that is going in those buildings, operation of those buildings, is what will give us significant amount of scope 2 emissions, and we are trying to reduce that through this exercise. Let us look at another example, which is of Bhavar residence in Chennai. So, this is a very interesting example, and Chennai, we understand it is warm and humid, and there is a lot of humidity due to the proximity to the sea, and it is also decently warm. So, what they have done is, the first thing is the design, as I always say. So, they have rotated the plates beautifully to enhance the Venturi effect in the atrium. So, there is an atrium, so not a courtyard like the previous example that we saw, but an atrium which facilitates light and also ventilation, both of these things. An open courtyard also facilitates light and ventilation. Here the atrium is facilitating the light and ventilation. I will probably not need to explain all the case studies, because the points, the strategies are going to remain the same. So, if you look at the strategies here, daylighting, which is what we have seen in the previous one, all the areas are daylit for almost entire day. 99% of the times the illuminance levels are exceeding 110 lux, which implies that none of the areas, habitable areas in this residence, will require artificial lighting during the day, which is a significant cut down on the energy requirement. Then landscaping, a lot of landscaping has been added in this residence, as we can see in this photograph, and this reduces the heat ingress to the inner areas. Facade and envelope. So, now this is one thing that we can discuss, and which can be criticized also, is that the facade of this building is covered in zinc panels. Now, zinc is a corrosion resistant material. Chennai, because it is warm and humid and has proximity to sea, is prone to corrosion. Lot of building materials, they corrode. So, to avoid this particular problem, to take care of that problem, they have used zinc panels. Now, zinc, since we are looking at scope 1 and 2, this will perform good, because we are anyways adding the insulation will reduce the energy consumption. But if we are looking at scope 3, this may not be the best solution, because zinc will be associated with significantly high embodied energy and scope 3 emissions thereby. So, if we are looking at, if we are including scope 3, zinc will not be the best material to be used. However, if we are only concerned about scope 1 and 2 here, we will see that this performs good. Again, water management. So, they've gone in for rainwater harvesting, and again, as I say, the moment we are saving water, we are saving on pumping requirement, we are saving on a lot of energy there further. Then we are talking about materials. So, though zinc has been used, other materials that has been used is having a recycled content. Now, this is going in scope 3. Together, if we put use of zinc panels and the 33% of recycled material, we will still get very high scope 3. So, from the point of view of scope 3, might not be the best case study, but if you look at scope 1 and 2, the strategies will remain the same. Once the design has been done properly, then we go to MEP, HVAC systems. So, they have used variable refrigerant flow, VRF, which is having a very high coefficient of performance, which is around 5.55 at 70% capacity, and it is a very high, very good coefficient of performance. All the appliances that have been used are 5-star rated, for example, fans and geysers and everything, and hot water needs, they are met using a heat pump, which again has a very high efficiency, and they are generating their own energy through the limited roof space that is available. But since the energy needs of the entire residence have been significantly reduced, a substantial portion of this energy consumed is being generated at the site itself, though the site is very small, but the design facilitates the reduction of energy consumption and offsetting some part of this consumed energy through the energy produced here. So, the strategies more or less will remain the same. Again coming to this next case study, which is Jaguar headquarters in Manesar, Haryana, which is again a composite climate. So, here what we see again the first form and massing, how the form has to come so as to reduce the heat ingress into the building, but at the same time allowing for significant daylighting to be there. Now, coming to facade and envelope, again here they've gone in for zinc. So, keep in your mind the scope 1, 2 and 3, the impacts on all these 3 scopes. What is beautiful about this particular design, because there is a lot of space, there is a lot of land which was available, is that they have gone in for biophilic design. So, Jaguar being a company where water is at the core of it, so what they have done is that they've invested in this biophilic design. So, lot of green spaces have been provided outside on the terraces of this particular building, and which creates a microclimate of the sort and reduces within the larger climate category, it reduces the heat load of the heat ingress of this particular building and thereby the cooling load. So, it is a climate responsive design, and all the passive design strategies of planning the building properly, they have been followed. Once that has been done, they are now moving on to MEP, where the cooling systems, so they've gone in for central air conditioning, and it is a conventional cooling system plus the radiant cooling and a heat pump plus a VRF, both indoor and outdoor. So, together this is a highly efficient HVAC system, the cooling system, which has been installed. So, first designing the building correct and then adding the active strategies. So, we are talking about radiant cooling systems, all these strategies we have discussed, they are highly efficient strategies for mechanical systems, heat pump, VRF and radiant cooling. Then we come to ventilation system. Again the ventilation system has been planned in such a manner. Now, unlike Chennai, Manesar in Haryana is, since it is composite climate, will also witness winter months, severe winter months. So, what they have done is that they have also commissioned the heat recovery units to utilize the cool return air and also to utilize the heated air in the winter months. And all the exhaust fans and efficient heat recovery system has been installed to make this ventilation system more and more energy efficient. Coming to lighting design, again LEDs have been provided in the entire office building. But before going to that, before coming to artificial lighting design and choosing LEDs, the building has been designed so that more than 75% of the total habitable areas are daylit. And additionally, water efficiency. So, potable water is supplied by the municipality and treated sewage water, of course, the uses differ. So, thereby reducing the requirement for pumping more water. There is also the rainwater harvesting, the 50% of the wastewater is treated and recycled on site and used back into the system. So, overall the water consumption is reduced, there is very high water efficiency that they have installed. Jaguar being a company which is totally invested in fixtures, water fixtures, plumbing fixtures. So, they've considered water efficiency in this entire building very seriously, and this is further resulting in lowering the energy consumption. Once the energy consumption has been reduced, the building has been designed and constructed as energy efficient. On top of that, they have used solar photovoltaic module. So, crystalline high powered solar cells. Overall, the installed capacity is around 970 kilowatts. So, around 122% of the electricity that is consumed is generated on the site itself using these solar photovoltaics, and it makes this building not just net zero, but an energy positive building. It gives back to the grid. So, overall energy consumption has to be reduced first, which has been done, and then offsetting the energy through generation on site. Now, all these three case studies that I have shown you, we have seen similar strategies being used, and that is how we will reduce the scope 2 emissions in any building, reduce the energy consumption and produce the whatever energy is being consumed on site itself. And photovoltaic, because we are a tropical country, almost throughout the length and width of the country we receive fairly good amount of sunlit hours. So, photovoltaic comes out as one of the most promising strategies for generating renewable energy, and that has been, as we see, that has been exploited in most of these case studies. The last one is Indira Paryavaran Bhavan, and pretty much the same strategies have been utilized here also. So, this is the Office of Ministry of Environment and Forest, MOEF. It is grid connected and it was designed as a net zero energy building. Now, this particular building uses 70% less energy as compared to a conventional office building, which is a significant reduction. Lot of strategies have been used. So, what they have done, that they have designed this building in a manner that there is open area. So, this is the landscaped area that they have created. There are 4 towers which go to G+6 floors above, and they shade this landscaped area partially. And on top of this entire building, as you can see in this particular picture, they have extended the frame to support the photovoltaic cells, the solar cells, and it acts as a second roof, a shading roof on top of this entire structure, which shades the landscaped area as well as the building part. And the building is also connected at some of these points in between as bridges, and together they are able to produce 100% of the energy that is required in this building through the photovoltaic cells that are there. And before that has been planned, the passive design strategies have been put in place correctly. That includes orienting the building correctly, landscaping, daylighting, ventilation. The courtyard helps in ventilation significantly due to the stack effect. Another very interesting thing, before I move to MEP, so there are building envelope and fenestration design. So, the building envelope, window assembly, the glass that has been used, the insulation in the walls that has been used. So, all those passive design strategies have been correctly implemented here. And when we are talking about material and construction, AAC blocks with fly ash. So, a lot of discarded waste material has been used, fly ash based plaster and mortar, then stone and ferro cement jalis have been used, the flooring has been done in locally available stone, bamboo jute composite doors. So, now here, though majority of these are not going to impact on the energy consumption of the building, but most of these materials that we are seeing here, they have low embodied energy. So, this particular building is highly acclaimed for this reason, that it is not just about scope 1 and 2 that is being considered here, we are also reducing the scope 3 emissions due to this building, construction. Now, when we come to active strategies, so they have used chilled beam system, variable frequency drive and screw chillers, together making the entire cooling system, the mechanical system as highly energy efficient. But the most interesting part is that this is one building which employs mixed mode of air conditioning, cooling and air conditioning. So, during the period when the outdoors are comfortable, the windows are allowed to be opened by the users. The users can open the windows, and the air conditioning system will not be run when the temperatures outside are comfortable, when the windows natural ventilation and mechanical ventilation can be turned on. Only during the peak months of extreme summers and the humid months of monsoon and the extreme winter months that the HVAC is run. So, together this building has significantly lower energy consumption with the help of this, and there are other strategies: lighting design, optimize energy systems. There is also a geothermal heat exchange system that has been installed in this, and 180 vertical bores to the depth of 80 meter all along the building premise, they have been provided to provide for this geothermal heat exchange system. So, before running the HVAC, the pre-cooling and preheating is done using the geothermal heat exchange. Once the energy consumption was reduced from the conventional building consumption, if we considered, by 70%, which is a significant, which is very huge reduction, the required energy is now being offset by producing renewable energy through this roof shade that has been provided. And overall, the solar PV system of 930 kilowatts capacity is installed, and the actual generation it produces around 300 kilowatt hour per day. So, which is significantly high given the small footprint that this building has. So, overall this building achieved an absolute net zero energy status, and in certain months it becomes energy positive as well. It sends back to the grid. So, these are some of the case study which clearly demonstrate how building, any building for that matter, we have seen largely office buildings, some standalone office buildings like Indira Paryavaran Bhavan, or some with industrial units at the back where a large roof surface area was available, or even residential building. It is absolutely possible to have a net zero energy building on site itself. A lot of these strategies, it appears that will consume a lot of extra capital to be invested right in the beginning. Some of these strategies surely do. For example, geothermal heat exchange, it will require significant amount of capital to be invested right in the beginning. So, there we have to make a judicious choice as to which strategies to adopt and which strategies to not, but these I am talking about advanced strategies. Passive design strategies, architectural design, the choice of materials surely does not cost us anything extra. We have to be conscious right in the beginning that the design be made in such a manner that the energy efficiency is achieved through the design itself, and design has the potential to reduce the energy consumption by as high as up to 40%. So, if we have designed the building rightly, keeping in mind what materials will we be needing, which we will be proposing, we will be able to reduce the energy consumption of any building by 50% very conveniently. Further, to reduce the energy consumption, we can go ahead with the active energy systems, the active systems, reducing the lighting load, reducing the load for mechanical HVAC systems, reducing the load for the water supply. Once we have added that, it is not difficult to further reduce the energy consumption of the building and then produce a significant amount of that through on-site renewables. I hope with this we have clearly understood that how much of scope 1 and scope 2 mainly emissions can be reduced. The moment we say reducing energy consumption, overall energy consumption by 80%, it automatically implies reducing scope 2 emissions by almost a similar percentage. So, if a business, for example, an academic campus, a university campus, or say an IT company or a call center or a data center, if we are talking about these businesses, these companies which have significantly high building assets, the scope 2 emissions can be brought down to significantly low numbers just by designing the buildings right. So, if we are able to design all the buildings right, we will be significantly bringing down our energy consumption is the bottom line that we have to understand out of this entire discussion over the last 7 weeks. With this, I will stop here, close this lecture, and in the last week of our course, we will be looking at how much exactly are we able to reduce the scope to. So, we have seen strategies, we have seen cases, now we will go on to exact calculations as to how much exactly emissions have been reduced through adopting of these strategies. So, thank you very much for being with me. I will see you in the next week with new set of lectures. Thank you. Bye-bye.